Good afternoon, everyone. I'm very pleased to see some people here. I know it's very difficult to come in such bad weather. But obviously, I'm going to talk about climate change, and for Hong Kong, it's the most pressing issue for every resident of Hong Kong. So really, this lecture theatre should be standing room only, not relatively absent. But I've been given a gift by the Hong Kong Observatory, yeah? And it's a set of reusable ice cubes. So that's good because that's sustainable, but they're reusable ice cubes on a tropical cyclone warning. So you've got the scheme that you have within Hong Kong of Typhoon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously that's a very appropriate gift, seeing as at the middle of next week, probably Wednesday, every single person in Hong Kong, life is going to be disrupted by a typhoon. I don't know what category it will be when it lands, but it could be category 8. What was it in August? You had a typhoon 10. Yeah? So in the last 6 weeks, you will have had 2 large-scale typhoons. So I can take those out. So I've lived in Hong Kong for 5 months, and I have experienced a typhoon 10. Next week, I will experience a typhoon 8. And I will tell you as a matter of fact that at some point in the next 5 years, you will have a typhoon 11, a typhoon 12, a typhoon 15, a typhoon 20, because that's the problem with climate change. Everything that every one of you have experienced in the past is irrelevant because of what's going to happen in the future. So I didn't know I was going to get this gift. Thank you very much to the Hong Kong Observatory. It's just incredibly appropriate. Okay. So I am a climate scientist. I work at a city university in Hong Kong. I'm the Dean of the School of Energy and Environment. Before working in Hong Kong, I worked for the Singaporean government for 8 years, developing their national sea level program. So the Singaporean government were exceedingly worried about it being an island nation, being very susceptible to sea level rise, so they began a national sea level program, and they hired me from the United States. That's where I was for most of my career, although I am British, so I spent most of my career in the United States, and then I moved over to Singapore to begin the national sea level program, and then I was headhunted by the City University of Hong Kong to build a climate school, and I'll mention this on my last slide. So I'm just going to go through some slides with you. The first one is to put my life or my career alongside the signals of climate change. So to begin with, I was born, that's a little photo of me, okay? I was born in 1971. And we're going to have a series of graphics here. In the blue is the temperature, which is on the left-hand side, and in the dashed line is the amount of carbon dioxide on our planet. So when I was born, temperatures had risen maybe about 0.2 of a degree C above the pre-industrial values, and carbon dioxide values were around a metric known as 330 parts per million by volume. At the same time, 1 year after my birth was the first time that the United Nations recognized that rising carbon dioxide concentrations would cause rising temperatures, which would lead to Droughts and wildfires would lead to rainfall and landslide and an ever-increasing number of tropical cyclones or typhoons. I then went through going into high school. When I went into high school, the temperatures had risen to around 0.6 of a degree C above the pre-industrial values, and our carbon dioxide values had increased to around 350 parts per million by volume. We then moved through to the Intergovernmental Panel of Climate Change. So that's when the United Nations first selected a panel of the best scientists in the world that would review the state of the climate. They produced the first Intergovernmental Panel Climate Assessment Report in 1990. Now, that was the time period when I went to university. So when I went to the university, I went to the University of Durham in the United Kingdom. I took a course on climate change, and the prescribed reading for me was the 1990 Intergovernmental Panel of Climate Change report, the first assessment report. And I read that as a 21-year-old boy, and I read about this report telling me that if we don't stop our emissions, that our temperatures would rise. We would therefore get melting ice sheets and our sea levels would rise. We would increase the heat of our oceans. We'd get more tropical cyclones. With the increase in heat, we'd get droughts. We'd get wildfires. We'd lose our crops. We would cause heat waves. And I was fascinated by that topic. And I thought I would dedicate my career to better understanding it. We then had the first, as a result of the IPCC, we had the first COP meeting. The COP stands for Conference of Parties. So the parties are governments, and where the governments come together to try to slow down our emissions, move towards renewable energies, protect nature, and provide assistance to communities that are going to be impacted by climate change. I then earned my PhD in 1999, having spent 4 years of my life studying sea level rise. But when I was doing my PhD in 1999, our temperatures had now gone up to nearly a degree above pre-industrial temperatures, and the amount of carbon dioxide in our atmosphere had not slowed down. It was increasing to around 380 parts per million by volume. I then moved over we then had the third assessment report coming out, and then I moved over to the United States in 2004 with my young family, with my wife and my young daughter. So we moved in 2004 to the United States, and I became an assistant professor at the University of Pennsylvania, which is one of the Ivy League universities. At the same time that I came over, The Inconvenient Truth came out, which is perhaps the most powerful climate documentary of all time. This was produced and delivered by Al Gore, who was a presidential candidate to succeed Bill Clinton. This then elevated, particularly in the United States, climate change from being a science-based topic to being one of public debate. And therefore, as a climate scientist, I then had to make sure that I was able to deliver my science to the people. And this is what I'm continuing to do here in Hong Kong. I started this some 20 years ago, thinking that I had a responsibility, because of what I know about climate change, to deliver a talk on a Saturday afternoon when it's very wet in Hong Kong, because it's my responsibility. And I don't really mind if there's one person here or 1,000 people here. It's my responsibility to try and educate you about this impending problem. The first climate agreement to reduce our emissions was in 2005, called the Kyoto Agreement, signed by all countries of the world at that current time, including the United States, including Iran. Subsequently, when they changed their party to Republican, they removed themselves. It's a pattern in the United States. We then moved through to COP COP15 in Copenhagen, another attempt by the United Nations to have an agreement on climate change. At that point, all of the countries in the world, apart from the United States and 2 others, agreed to reduce our emissions. I then, in 2013, became a full professor. I went from an assistant to an associate to a full professor. On the back, one of the pieces of work that made me a full professor is that I contributed to the famous climate agreement called the Paris Agreement. So the Paris Agreement was at the COP21 meeting, and that stated that all the countries in the world, including the United States, had agreed that they would limit the global mean temperature increase to less than 1.5 degrees C above present. My contribution to that is that I was part of a global consortium of scientists to look at the stability of the Greenland and Antarctic ice sheets at the poles. And what we said, and I'll talk a little bit about this towards the end of my seminar, is that if you went above 1.5 degrees C, those ice sheets would begin to collapse. We then move forward to 2020. In 2020, I moved over to Singapore. I became the director of what's called the Earth Observatory of Singapore. And as I stated earlier, it was about developing a national sea level program. But nothing changed with our temperatures. It didn't matter of any of these reports. By the time I moved over to be director of the Earth Observatory of Singapore, on the carbon dioxide values, we had crossed 400 parts per million by volumes, and our temperatures were now 1.2, 1.4 degrees C above present. In 2023, the latest assessment of the Intergovernmental Panel of Climate Change, and in my role, I became the review editor of the IPCC. So my role within the IPCC is in the 3rd assessment report. I contributed some papers. In the 4th assessment report, I became a chapter author. In the 5th assessment report, I became a contributor. And then in the 6th assessment report, I became an editor. So my career, my scientific career, has been absolutely, and I will say this, phenomenal. I did my PhD. I became an assistant professor. I became an associate and a full professor. In climate circles, I went from a contributor all the way to being a review editor. I eventually became a director, and now I have the great, great honor of being a dean of one of your universities. But on climate facts, the amount of temperature and carbon dioxide, I have been a complete and utter failure. I don't know how many people I have talked to in my career. 100,000, 500,000, maybe with some of my online presence, maybe 1 million or 2 million people. But in that career of mine, in my life, I'm at a point where in 2025, our temperatures now exceed that threshold that I dedicated my life to producing a report in 2015. In my life, I have had no effect in the amount of carbon dioxide. We're now topping out at 425 parts per million by volume. And the year I became the dean was the year the Department of Energy in the United States produced the most damaging report on climate change, denying that carbon dioxide is a pollutant, stating that carbon dioxide is beneficial for you. So on Wednesday, when your lives are completely disrupted by that typhoon, when your life is disrupted by that typhoon, remember that the US government says that carbon dioxide is not a problem. Just look at all of these events of this year in Asia. This is just while I've been in Hong Kong in the last 5 months. Look at the number of typhoons that you are impacted by. And Next week, I'm going to add to that list. And the week after that, I may add to it. In actual fact, I'll probably need to create a new slide this time next week. It's staggering, the climate impacts. And it's staggering the lack of response of governments to this problem, to keep you safe, to keep you secure. These are records of global mean temperature on planet Earth. Increasing, accelerating. So we have this, I'm going to move away a little bit. I'll just keep my voice high. So this is the pre-industrial period, 1850. Then you have the industrial revolution. Carbon dioxide starts to pick up. Temperatures start to rise. Temperatures stabilise in this period because we have very dirty air, so it was reflecting a lot of the incoming solar radiation. We cleaned up our air, CO2 started to increase, accelerate, and accelerate. 2024 in Hong Kong was the warmest year since records began in the 1880s. So, the person who just left works for your government on climate change. And 2025 broke all records. These are carbon dioxide records. Okay? So, we record carbon dioxide in our atmosphere every single day. Every single day since 1950. Every single year, carbon dioxide increases. Every single year. But we know much, much more about carbon dioxide. This is the instrumental record. But in Antarctica, we can look at... Oh, right, brilliant. Oh, thank you very much. That's much easier. In Antarctica, we can take ice cores out of the ground, and they have air bubbles in them. The air bubbles record the atmosphere when the snow fell on the Antarctic ice sheet. Carbon dioxide has varied through time. Of course it has. Earth's climate has varied through time. We have an amazing history of carbon dioxide. When it goes up, temperatures go up. When it goes down, temperatures go down. And these are all phases in the Earth's climate system. We have records of carbon dioxide going back 800,000 years. The science that my community knows about climate change is absolutely phenomenal. And look where we are now. That should really worry you. That our carbon dioxide values are now at 420 parts per million by volume. We don't have accurate estimates, but we can make a very educated guess that the last time we had carbon dioxide values in the atmosphere the same as today was 2.8 million years ago. 2.8 million years ago, the Earth, through plate tectonics, started to break up. We had a lot of volcanic activity, which put CO2 in the atmosphere. 2.8 million years ago, with the same amount of carbon dioxide in the atmosphere, caused our temperatures to rise 3 to 5 degrees C. Exactly what our climate models do. In terms of the ice sheets at the poles, the work that we did on that showed that 2.8 million years ago, Greenland and Antarctica had collapsed and sea levels were 20 meters higher. So that's the implications for you to think about, is that with these carbon dioxide values, you will get a 3 to 5 degrees C warming. Just think about your daily lives. Think about how hot that would be. Think about the hottest days. We had a heat wave in June. We were talking about 38, 40 degrees C. Add another 5 degrees C there, and then keep it at that level. You're going around Victoria Harbour, try and estimate, a 10 to 20 metre sea level rise is higher than the height of this building. at this auditorium. So try and think about how you would think about protecting Hong Kong. So just to try and illustrate this sort of very clearly, and I show this graph because the bottom part of it on global sea levels is, I would say, my contribution to science, mine and my group. So so what you have here is you have the carbon dioxide records at the top, so they're instrumental records, and then the ice cores. Then you have temperature records, instrumental, and then the geological record, we could call it, comes from tree rings. So the width of the trees rings tell you what temperature is, whether it's warmer or cooler than today. And then on the bottom diagram is really what I started off in my PhD in the 90s and then finished off doing in 2022. And what we were able to show is the instrumental record and then the geological record. And so from all of this, what you can show is that really when you had the invention of the steam engine, you went from stability to rising temperatures, sea level, and carbon dioxide. So this is so going back to my first slide and talking about the Paris Agreement, the reason we had this threshold of 1.5 degrees C is because once you went above that, you had problems to do with tipping points in the Earth system. So once you went above that, the West Antarctic ice sheet could collapse. Once you went above 1.5 degrees C, the West Antarctica can collapse. Once you go above 1.5 degrees C, the Amazon rainforest converts into a savanna. The Amazon rainforest is the lungs of our planet, produces around 40 to 50% of the oxygen that we breathe in. If you turn it to a savanna, we have an inability within the atmosphere to produce sufficient high-quality oxygen. We have mangroves and salt marshes that litter our coastlines. They vanish. Coral reefs. If you go above 1.5 degrees C, around 99% of corals become extinct. Think about that. The Great Barrier Reef has been on our planet for 25 million years. Within the next few decades, if we don't do anything about climate change, it becomes extinct. 40% of the protein on our planet comes from fisheries. Where do those fish predominantly breed? On our coral reefs. So if you're worried about the protein in Hong Kong, particularly if you have a pescatarian or a fish-based diet, significant problems. Permafrost. In the Siberia, the ground is permanently frozen, locking in the most potent of greenhouse gases called methane. You go above 1.5 degrees C, it melts and the methane is released. Greenland ice sheet, you go above 1.5 degrees C, it vanishes. The Arctic sea ice, which acts as a mirror for our planet, when solar radiation hits the Arctic, the ice reflects it back into the outer atmosphere and into outer space. It vanishes. And then the one that we're really, really worried about is ocean circulation. And that's what I'm going to talk to you about for the next couple of slides. So all of these thresholds, there are 9 of them. This is the science basis of the Paris Agreement. They're large, huge impacts. Crossing these thresholds is accelerating, and they're often irreversible. So you guys all lived through the pandemic, COVID-19. I lived through it in Singapore. When the COVID pandemic was upon us, it was incredibly worrying for us. But then a group of young, dedicated scientists found a vaccine, saved millions of lives, and we could go back to living as normal. What I will tell you about climate change is that there is no vaccine. Once you've crossed these thresholds, there is no coming back from it. You melt an ice sheet, you cannot regrow it. It takes about maybe 100 to 200,000 years. You don't regrow it in a human lifetime. So as soon as you go above 1.5 degrees C, each one of these, we're rolling the dice every single day on collapsing any one of these, and we have 9 of them. So we're going to look at this ocean circulation. It's known as AMOC, the Atlantic Meridional Overturning Circulation. It is massive. The volume of the water in the North Atlantic is greater than the volume of all the rivers on planet Earth. The water moves from the tropics to northwestern Europe. When it is in northwestern Europe, the water becomes very, very saline, a lot of salt in it. It's very, very dense, and it sinks to the bottom of the North Atlantic Ocean. At the bottom of the North Atlantic Ocean, it then moves, it's called the Great Conveyor. It moves from the North Atlantic all the way to Antarctica. It takes around 400 years for this movement of water to come up at Antarctica, where it upwells and then circumnavigates the Antarctic ice sheet. It then sinks again and moves into the Pacific Ocean, moves into the Indian Ocean. This great global conveyor transports heat around the planet, transports oxygen around the planet. This great global conveyor keeps our climate stable. But it is very, very sensitive. The sinking of the water in the North Atlantic is related to salinity. So if you lower the salinity in the North Atlantic, you slow down and stop the circulation. How can you change the salinity? You would need a colossal amount of fresh water nearby. What do we have at the North Pole? In the North Atlantic, you have the Greenland ice sheet, the second largest reservoir of fresh water. You melt the Greenland ice sheet, you disturb the salinity in the North Atlantic, you slow down this circulation. And this is something that has worried scientists for a long, long time. And the latest research says that this circulation system will collapse in a few decades. The latest research puts the median year, the 50th percentile, our most likely guess, at 2055. 30 years. I may be around to see it. My kids will be. 30 years. What are the impacts? Well, in northwestern Europe, because you're not transporting heat from the tropics towards the poles, the temperatures plunge within a decade by 15 degrees C. That collapses a sector, collapses agriculture in northwestern Europe. If you want to just think of it as an example, if you've been to Stockholm or Copenhagen, their summertime temperatures will never get above freezing. Their wintertime temperatures will be minus 20 degrees C. Northwestern Europe is frozen. Northwestern Europe collapses. Irrespective of what happens to our coral reefs, because the ocean conveyor distributes heat and oxygen around our oceans, our food web collapses and stops in our oceans. And if we really want to delve down into trade routes, Hong Kong is a massive port, Singapore was a massive port. Trade routes completely have to be rewritten because the northwestern Atlantic is frozen. AMOC weakens. It means that our oceans, this is this accelerating impact of tipping points. So AMOC weakens, it means that the ability of our oceans to absorb carbon dioxide weakens. That accelerates global warming, increases the cost of these emissions. AMOC weakens, it causes extreme weather. So if AMOC weakens, you know, these ice cubes will be out of date. I'll have to have, the Hong Kong Observatory will have to deliver me a new set that has Typhoon 11, 12, 13, 14, 15. Sea level rise, we're going to get an extra 1 metre of sea level rise endangering cities. And then this one again, it has knock-on effects. The Amazon rainforest completely and utterly collapses. And just remember the date of that. So climate change is not something that we think of, oh, it's for my grandchildren. I mean, you know, we, as climate scientists, I used to always think that if I told an audience or I told a governmental official that you need to save planet Earth for your children or your grandchildren, that was emotion enough. But now, and I don't want to be rude, but if I look at certain of you in the audience, this is your life. This is your life because the median, the 50th percentile, is 2055. And that's the median. If we go really extreme, it could happen in 10 years' time. Remember, we have an uncertainty. The median's 2055. Well, we could get it wrong, and it could be 2075, 2085, 2095. But just as easily, we could get it wrong, and it's 2045, it's 2035. It's a really serious issue, people. This is a video of a drone shot when I last went to Antarctica in 2022. I wanted to show you this because of the colossal size of Antarctica. This, I mean, you know, so this is our research vessel that we went on. It's an old World War II refitted Yugoslav vessel. So that's the sort of work that we don't go on some luxury 5-star cruise liner, but it's a big boat, okay? Housing about 200 to 300 people on that boat. And I just want you to have a look at it in compared with the size of a small portion of the Antarctic ice sheet. And these ice sheets, because of our increase in temperature, are just losing mass. So this is Antarctica, and the graphic of Antarctica, where in red is showing where the hotspots are. And Antarctica is just distributing gigatons of ice into the ocean. A gigaton is 1 billion tons of ice every single year. Greenland is more sensitive, and that's why this worry about Antarctica. Greenland's more sensitive. You can see as we go towards the last few years, virtually the whole of the ice sheet is now disintegrating. Remember, this is all what scientists had warned as early as the year I was born. And your governments did nothing. Now, these ice sheets have this potential when you go above 1.5 degrees C of just simply collapsing. The ice sheets at the edge, they just collapse. They don't collapse in a slow, gradual manner. We know the processes. It's because they get warming from above from solar radiation, and they get warming from beneath from ocean circulation. I'm just going to skip this slide. And I'm going to show you, this is Hong Kong. So my group produced the most accurate projections of sea level for Hong Kong. The lady who was from the Hong Kong Observatory have their own estimations of sea level. And they estimate that in a high emission scenario, sea level will rise 1 meter. Our estimates, based upon the latest data, say under a high emission scenario, the upper estimate is over 2 meters now within this century. And that just gives you an indication that the Hong Kong government, they're using the latest IPCC report, which I was the review editor, but it's already out of date. And so we want to get a better partnership with the Hong Kong government to give the best possible information. So I just want to sort of finish with the hope with climate change is because we still have time to solve this issue. It's a significant problem for Hong Kong in terms of flooding, contaminating water, the heat and the humidity that you have experienced. We have in Hong Kong, like many cities of the world, aging infrastructure that is vulnerable to extreme weather. The response of the Hong Kong government to a typhoon is what? Shut down the city. So if you're just going to have an increasing frequency of these events, are you just going to continue to shut down the city? How many days in August was the city shut down? What is that cost on people's livelihood? It has significant impacts already, climate change, on supply chains and increased costs. So when I came here, I was asked to try and come up with a plan of how can Hong Kong get itself out of this problem. And I wrote in the South China Morning Post about my sort of 8-point manifesto. So the first thing to do is we need to make sure that we invest in the climate science. I'm part of that investment. The City University of Hong Kong, using taxpayers' dollars, hired me. They've given me money to hire a further 5 professors on this topic. So this time next year, if you're looking for a speaker on climate change, it's not just me, it'll be me plus 6 others. So each one of us will build a team. Each one of us will have undergraduates, PhD students, and postdoctoral scholars. I would suggest in 3 years' time, instead of it just being a single person working on this topic in Hong Kong, we will have 50 or 60 or 70 people working on this topic. So we're starting this process. We're investing in climate science. But we must accelerate our renewable energies. You know, it's quite interesting why we don't use more renewable energies in Hong Kong or in Singapore. The price of renewables in terms of solar are cheaper now than petroleum. The price of petroleum in energy has not really changed for 140 years because the technology is still the same. We still need to derive it out of the ground. It's incredibly expensive. Solar has decreased in cost and it will increasingly be cheaper. But we need to employ it. And all of you know why we don't use renewables. Because of policies and persuasion by the petroleum industry. We need to have strategies for the city that we call no regret. So if we solve climate change, there are other positives that come on top of that in terms of your finances or your health or your biodiversity. We need to make sure the city is prepared for typhoons. It cannot keep simply shutting down. I know that because the disruption, you know, next week on Wednesday, I'm already cancelling all my classes, cancelling all my meetings. But when do we have the time to rearrange them? We must strengthen climate resilience. I must say Hong Kong is very resilient to the climate of the present. When it rains, even a black rain event, the day after, you can go back to work. We don't have landslides influencing it, even though we're in a mountainous region. But as I said, the climate of the past is history. We need to make sure that Hong Kong is developed for the climate of the future. We desperately need to engage the community. I certainly don't want to come across as some foreigner who's come into Hong Kong to tell you what to do. I want to educate. I want people to have community action that they want to solve this for themselves. And we must improve transparency between all nations on how we're going to act. This is a global problem, requires a global solution. Climate change, unfortunately, despite its impact on everybody's lives, is never discussed at the top table. So we've all been fascinated this week, well, I have because I'm British, but been fascinated by Donald Trump meeting Starmer. But do you think at any point, and including Prince Charles, at any point in that 3-day visit that the word or the phrase climate change was mentioned? Do you think at any point they discussed that problem? You know that they didn't. Did any of the media ask them about that problem? Even though 75% of England is under drought warning right now. That staggers me. I grew up in Manchester. It rained every single day. Manchester is now under a drought warning. Half of the United States this summer was under a heat advisory, influencing 175 million people. But was it discussed or was it mentioned? And then finally, we need to support the most vulnerable. Here in Hong Kong, who does climate change impact the worst? It impacts the elderly, those over 65. It impacts the young, those under 4, and it impacts those with pre-existing conditions. So my son, who lives in Hong Kong, he's diabetic. He has type A diabetes, which means when it gets very, very hot, if he has high blood sugar levels and his blood is thick, he is under danger. And in the June heat waves, my son collapsed. Nobody else did. All the other school children didn't have diabetes, so their blood was able to cool them. My son was fine, but he collapsed. And that's why climate change is very emotional for me, because I know that my son, because of his pre-existing condition, will be affected first, not his friends that don't have diabetes. And this is what we're trying to do at City University of Hong Kong. We're trying to build a climate school because I believe every one of your children, every one of your grandchildren need to be educated on climate science. They need to know whether they're going to become a doctor or a lawyer or work in business. I want them to know about this problem. I want them to think about it and I want them to solve it. So we have these very, very big sort of KPIs. We want to, in the next 5 years, educate over 500 students in climate science. We want to produce manuscripts. We want to influence policy. And I want to engage 100,000 people in Hong Kong in 5 years. And sort of like, I don't know, we've got like 25 of you. You're the first 25, okay? So you get a certificate for being the first 25. So how I'll just sort of conclude this is well, I want you to be a partner to this, okay? And a partner means that when you leave this room, you say, you go and talk to somebody about this problem. You say that, well, I spent 45 minutes of my afternoon listening to this English guy talking about climate change and saying that we have 30 years to solve this problem, but we still have hope. Just talk about it. That's being a partner for me, because we have an incredible problem in front of us. To give you one last sort of like sound bite, how many people are there on planet Earth? 8 billion people. If AMOC collapses and the other tipping points, we estimate that the Earth can only support 1 billion people. That means 7 out of 8 people don't reach their life expectancy. That is how severe it is. So if you were a segment of the population, there's 25 of you here, okay? Only 4 or 5 of you would reach life expectancy. The rest wouldn't. Your life would be shortened by the availability of food, water, and a place to live. But on the flip side of that is that we have time. We have time as long as we act. We have 30 years. It's like a clock that we should have up with a timer on it. And it's like tick-tock, tick-tock, tick-tock. I've dedicated my life to this. As I showed in my first slide, I wasn't successful, but I'm not going to give up because I care about my family, I'm very worried about my son, and I care about society. And I think we have the power to solve it. So thank you in actual fact, I'm really thankful that you showed up today. That means a lot to me. I know it's difficult in the wet. And all I please ask of you, one more favour, is that when you leave here, you just say, I heard a talk about climate change. It's worrying. We should do something about this. Thank you very much.
咁多謝晒 Professor Horton 嘅演講嘅分享啦。咁我想問有冇問題想問嘅 ？OK， 前面呢位先生先。
Are the nature-based solution or engineer-based solution for climate change mitigation more effective?
So you're talking about geoengineering, aren't you? Yeah? That's a really good question. So it's a question we don't want to, as scientists, we don't want to talk about because we had hoped that we would be using renewables right now. Yeah, we would hope, my first slide, if you'd asked me that question in 2015, I'd go, no, we're not dealing with it. We're not dealing, because we're going to listen to the scientists, and the amount of carbon dioxide is going to go up, and then it's going to peak, and then it's going to fall. Okay? But we have to admit now that our government, for some reason, didn't want to protect the people. The governments, for some reason, didn't want to listen to the experts. So now we need to think about engineering solutions. We just have to make sure that we make them very socially responsible. The engineering solutions cannot just be for the rich. Yeah? I mean, that's the key. So engineering solutions, because we know, again, this is why I want everyone to study how the Earth works. So then the best engineers can think about, well, how can I slow down this problem? And the best economists can think about, how can I fund this? And the best people working in the civil service can think, well, how can I make sure that it's not just the rich who are saved? Yeah? So engineering solutions, there are many of these potentials. There are ideas that you can fertilize the ocean. So if you fertilize the ocean, you produce more phytoplankton, which then absorb carbon dioxide out of the atmosphere. So that's quite a preferential one, okay? Because what we don't want to do is alter the amount of incoming solar radiation. Because then it becomes a little bit like Blade Runner, where you're still allowing people to pollute carbon dioxide in the atmosphere. You're just stopping solar radiation coming in. So it's these ideas of understanding how the Earth works. So if you produce more phytoplankton, they absorb more carbon dioxide, they'll store it in the ocean, you reduce the amount of CO2 in the atmosphere. We have other examples which I like. One of them is called enhanced rock weathering. So you basically fertilize the soils on our planet. Using basalt is a common example. So in volcanic areas, you would mine the basalt, you grind it up. Quite simply, you just sprinkle it on your soil surface. Basalt has the ability to absorb carbon dioxide out of the atmosphere, bury it in our soils. We have other examples of putting sulfur dioxide in the upper atmosphere. And that is a difficult one because it has a bias, because all you're doing is blocking out incoming solar radiation while you're ever increasing. You're allowing us to continue to, what we have to do, I think your answer, you have to do it hand in hand because we need to accelerate the renewables. Because if we just keep on increasing the amount of carbon dioxide, your engineering solutions are not going to work, but they are an option now. There are many other examples. People are thinking about greening the Sahara. So again, trying to create, the Saharan desert was green 7,000 years ago. And then our climate shifted and it became arid and it became a desert. So can you regrow it into a savanna, which then would absorb carbon dioxide out of the atmosphere? Solving the problem. Huge loss. Can you refreeze the Arctic and Greenland? So somebody in my university is looking at this. Can you develop technology that would lower the temperature of the surface ocean, so then it would refreeze the Arctic? It's a great question, but as I said, that's why everybody needs to be educated on climate. So we get the best engineers, we get the best finance people, we get the best government. Great question.
Okay, thank you sharing of from Professor Horton. 有冇其他問題想問嘅？前邊呢位先生。
How do you compare driving electric car and a petroleum car? I heard that electric car consume as much greenhouse gases by burning coal, but I heard another example from the KOL from YouTube's like if you drive Elon Musk's electric cars and installing solar roofs in your housetops, and then you can only use the solar energy to support your car energy, and then you don't need to pay anything for the electric fees.
Okay, another really good question. Okay, so the thing about it is that I've heard, so combustion engines versus electric vehicles, okay? So who do you think is telling you that electric vehicles produce as much carbon dioxide? Yeah, but I would love to know what he invests in. He invests in petroleum. I mean, just think about this. Just think about this. That your second point is which I want to get onto is like one of these sort of really important points. But the first point is just think about it. You've got an electric vehicle. Just look at the tailpipe. And look at a combustion engine, yeah? There is a significant difference. There are issues that you can, well, I mean, the thing about it is, there's lies, damn lies, and there are statistics. If you produce an electric vehicle and then buy another electric vehicle 6 months later, and then another one 6 months later, and then another one 6 months later, yes, the carbon used in producing that, compared to having a combustion engine car for 4 years, yes, you'll balance it up. But over their lifetime, the savings on carbon, and just think about it. I mean, if everyone was driving electric vehicles right now, if we're all driving EVs, and then someone came up with the invention of a combustion engine, and they said to you, oh, I've come up with this invention of a combustion engine. We're going to use the same engine for 100 years, because it's not really changed, 4, 6, 8 valves. How complex is it? Well, it's got thousands of pieces that are really hard to repair. Oh, how do you charge it? Oh, we don't charge it. What we have to do is drive around to some petrol station and fill it up. Okay? Oh, right. And then it just runs forever. No. You keep on having to do that every week because you run out of petrol. Conversely, an electric vehicle, you can charge at your house. Yeah? Mm. And if you have solar panels, it doesn't cost you any money. And that's the big thing about climate change, is that people think that the solutions are a problem. Climate change is huge, but the solutions are great, because if you have an EV vehicle and you have solar panels on your rooftop, or your community has solar panels and you're charging it up, it saves you money. Climate change does save you money. Climate change does make you healthier. If you eat the right food to save the planet, so you're healthier. Climate change certainly improves your mental health through biodiversity. But the key that I want to get to you is that if you just use an EV vehicle and the electricity is petroleum driven, doesn't do very much. But if you use an electric vehicle and the electricity is through renewables, it's called a super leveraging point. The total is greater than the sum of its parts. So that's the key. We can all try and buy an EV vehicle, and you can get this amazing rebate here in Hong Kong, which I did. Okay, that's exactly what I did. I came into Hong Kong. Didn't have these rebates in Singapore, and electric vehicles were quite difficult to buy. Everything was combustion. So I came in here and I heard about this amazing tax rebate. Okay, but I charge it up in my university. We don't have a lot of solar panels, but I've been trying to lobby that then we can do this super leveraging point. So the key is that we can do a lot. So if you think, to do with driving, if you buy an electric vehicle, but then you need to lobby wherever you work or your community to make sure there are solar cells so you get this super leveraging point. Very important topic. I think your first point is sort of true, that if you don't have renewables with the electricity, the gain isn't so much. But if you do the both, the gain is huge on our environment and the gain is huge in your wallet. So, I'm lucky. I live in a condominium that has solar panels. I've not paid I came here for $0. Got in my car, charged up my car overnight, came here, cost me nothing. I bought the car, I saved 70,000 US dollars. I mean, it's great.
Sorry, there's one more question. Can I allow to ask?
We still have time. Okay.
Do you agree with the idea of nuclear energy?
Nuclear energy. Well, my brother is a nuclear engineer. So my brother's a bit like Homer Simpson, I always tell him. He just sits there with nuclear safety. So nuclear energy has to be part of the solution. Just has to be part of the solution. It's not the solution, but unfortunately, again, because of the power of the petroleum industry, we have not invested in the science of nuclear energy for several decades now. The disasters at Long Island, particularly Fukushima, put a scare in the general population. Do they want to have a nuclear power plant? They're an incredibly safe technology, but there hasn't been the investment. Now everyone's thinking about these small-scale nuclear. I mean, because if you just think about the military, again, if you just think about, like when I was in the US, I did a lot of contracts with the US military. It's quite interesting. They sort of said phrases to me that, they've been the dominant military power for decades. Yeah, although China's trying to compete with that, but this big 5-star general once said to me, "We're not going to let climate change stop our military dominance." So they employed a lot of scientists such as me to look at how climate change would impact their strategic areas of interest. But I always knew. So we started working. I started to work out. Oh well, all the Navy in the US is all nuclear, the submarines, the aircraft carriers. And so they all run on these small-scale nuclear reactors, which are incredibly safe, produce very, very little waste product. So you can see it being part of the future. You can see Hong Kong having small-scale nuclear reactors in the next couple of decades. Singapore, so one of the reports, I knew people who worked in Singapore on the energy sector. They estimated that they needed 5 new small-scale nuclear reactors to basically power the city. So they were looking into that. And obviously right now we have the problem with AI. So our energy consumption was increasing in the developing world, but our energy consumption was stabilizing in the developed world until we had the explosion of data centers associated with AI. So we now have, until AI becomes more efficient, some of the Chinese chips, NVIDIA, are far more efficient. So we're going to have to think of how we're going to solve that matrix. And what we have a huge problem with is actually extracting enough petroleum so that's where nuclear reactors have started to come in. So a very good question, but that's that's part of the solution. So again, that's why when you think about when I want people to invest in climate change, it's also investing in nuclear energy to try and understand what are the safest forms, what are the most efficient forms of developing small-scale nuclear plants and also managing their byproducts.
Okay, thank you, Professor Horton. This is a very interesting and meaningful lecture。咁我哋今日科學為民服務巡禮嘅講座就嚟到呢度啦。咁下一節嘅講座咧，會喺10月18號同樣喺科學館演講廳舉行嘅。咁非常歡迎到時大家再到現場參加啦。咁今日嘅講座咧，其實之後都會上載到去 YouTube 去俾大家重溫嘅。有興趣嘅話，大家可以上到 YouTube channel， 我哋科學館嘅 channel 咧就去重溫翻今日嘅講座嘅。咁啊，科學為民服務巡禮由而家去到12月咧，一直會推出一系列嘅活動，包括論壇、講座、科學為體驗活動啊、工作坊同埋一啲嘅參觀活動。咁有興趣嘅人士咧，可以去到科學為民嘅網站去睇下嘅。咁再次多謝今日出席咁多位講者觀眾。咁啊，大家千祈唔記得去前台吸翻個印仔，攞翻我哋嘅紀念品啦。咁我哋下次見，拜拜。
Thank you.